This is a sample exam video for statistics for the exam over chapters 5 and 6. You'll notice that in this test you're not given very much of a reference section. You will get the formula for finding the z-value. You have to know what those terms mean. And you'll be given some probability tables. You're going to have to be able to answer some questions, not just do calculations in this test. And so I'm giving you the terms and the ideas that you have to know. So know these terms and ideas. You have two distributions, a binomial distribution and what's called the normal, Gaussian, or bell-shaped distribution. The binomial distribution is used for discrete data. The normal, Gaussian, or bell-shaped distribution is used for continuous data. That's a question on the test. You also have to know about the normal distribution. It can be called either normal, Gaussian, or bell-shaped. I use those interchangeably. This normal distribution gives probabilities for values less than, greater than, or in between two values. It does not give the probability for one exact value. There is a curve that's used all the time called the standard normal distribution. Standard means that the mean is 0 and that the standard deviation is 1. This is what they use to make the tables. So for this case, you have mu is 0 and the sigma is 1. That makes the standard normal distribution. If you want to use the tables and you don't have a mu of 0 and a sigma of 1, then you convert your data into a z-score. And here's your z-score right here. That's what that formula is. It's a formula to make the z-score out of some arbitrary x. So if your data has a mu of 25 and a standard deviation of 4, and you want to find the probability that of everything less than x, say, where x is 35, then you convert this to a z-score, and the z will be 35 minus 25 divided by 4, and that will give you the z-value, and you use that to look up the answer on the tables. It's common to write terms like this: mu plus or minus sigma, mu plus or minus 2 sigma, mu plus or minus 3 sigma. That notation means the mean plus a standard deviation and minus a standard deviation. It's discussing an area under the bell-shaped curve. This one is plus or minus 2 standard deviations away from the mean, and here plus or minus 3. So if your mean is 35 and your standard deviation is 3, then mu plus or minus 2 standard deviations is 35 plus or minus 6, which is 41 and 29. You'll have two answers for it. For the normal, standard normal, or normal, Gaussian, or bell-shaped distribution, that means all the same thing. The mean, the median, and the mode are all in the center of the graph at the peak. They're all together at the same place. On this test, you will need to know how to identify which areas have the probabilities of 34% and 13.6%. You also have to show with arrows regions about the mean where 68%, 95%, and 99.7% of the data lie. This isn't very hard, but you just have to flat memorize it. You can look in the text on page 304 or in the chapter 6 lecture notes. Here's an example. Here's your mean, also the mean and the mode for standard deviation. Moving up, taking the mean and adding a standard deviation and subtracting a standard deviation. Now look at the areas here. This area is 34%. This area is 34% of the area under the curve. This is your 13% one, and it's also symmetric. Here's 13% over here. Now 68% of the data about the mean lie here because you just add the 34 and the 34. The next one was the 95, and it's going to go from here over to here. And for the 99.7, it's out to the third standard deviation about the mean. This would be your 68%, say this is 95%, and this is your 99.7%. So you have to know that. So this is the type of question that will be on the test. It's a game show. You can choose between 3 doors. One door has a price of $1,000, another has a price of $500, and if you choose the remaining door, you get fined $2,000. So you need to fill in a probability table for the game. It would look like this. Well, first of all doors are equally likely to be chosen. So the probability of choosing each door is 1/3. The amount behind one door is 1,000. The amount behind another door is 500, and the amount behind the wrong door is negative $2,000. Because you're fined, you have to pay it. Then you need to graph that probability distribution. Okay, remember with these, when you have these discrete distributions, all you have are lines. So at each value, here's the minus 2,000, there was a 500, and here's the 1,000. They each have a probability of 1/3, which is 0.33, and all it is a straight line up to that value. This is for your discrete probability distribution, and this is uniform probability distribution because they all have the same value. It's not bell-shaped, it's uniform. And now you have to compute the expected value. Remember, the expected value, let me get the pen. So the expected value is going to be each value. First value times its probability, plus the second value times its probability, plus the third value times its probability. Well, here you see all the probabilities are 1/3. They're right there. And $1,000 first door, plus $500 for the second door, minus $2,000 because what would happen if you picked the third door. And the result is an expected value of negative $167 or so dollars. So this is a game in which you can expect to lose money if you choose to play it. There'll be an insurance question on the test. Here, the person wants to insure a Lexus for $200,000. And this particular person has a 10% probability of getting into an accident within 1 year. Right. Now, this is a little different from what you've done before and probably a little bit harder. You have to write the probability table. One entry is just going to be X, and that's the payment amounts. Okay, so if the person gets in a wreck, we're going to assume they get in a bad wreck and they have to pay the whole $200,000. So the insurance company is going to lose $200,000, but they get to keep whatever the policy is. We're going to try to figure out what we're going to charge this person. Now, if they don't get in a wreck, they have a 90% chance of not getting in a wreck, the insurance company just gets to keep the policy, the premium. I'll say that the insurance company wants to see an expected value of $2,000 to even agree to write this policy. So that would be the expected value. So let's calculate the expected value just as before, even though there's a variable in it, an X. So what the insurance company loses is minus $200,000 plus the premium, because they get to keep that, times 1/10, which is the probability they wreck the Lexus. Then there's a probability that they don't wreck it is 9/10, but that just times X. X is the annual premium. So X is the insurance for 1 year, insurance cost. It's what the insurance company is going to charge them. This is for 1 year. Okay, now we just go through here and solve for X. You take the 1/10 and distribute that through. You should be able to do that. So that's minus 20,000, I'm sorry, and they have 1x over 10 plus 9x over 10. That comes through. You can add those together and you get 10x over 10. What happened? Okay, so I think this is pretty wrong. Add 20,000 to get all the numbers over to that side. So you have 22,000 here. Add those together and you get 10 over 10, which is x. So x in this case is $22,000. So if the insurance company wants to see an expected value of $20,000 and the person wants to insure a Lexus for $200,000 and they have a 10% chance of getting in a wreck, they would have to pay $2,200 in insurance. That's pretty steep insurance. On the test, you're going to give a table of binomial distributions and you need to know how to use it. Okay. first column is N, the number of trials. X are the number of wins you want, and the top row, this p-value, gives a probability of winning. So you'll have to describe this table and then use it. First you have to define the variables. N is going to be the number of trials or games, perhaps. X is the number of games won out of the total of N games. So if I'm going to play 7 and I want to win 3, X is 3 and N is 7. P is the probability in decimal of winning one game. So now you have to use a table for finding the probability of winning 2 out of 4 games if the probability of winning a game is 0.6. This might be a little hard to read on this video, but to use this table, N is going to be 4, so here's your 4. X is 2 because that's how many wins you want to get. The probability is 0.6. That's right here in this column. And you look in this row over till you intersect that column, and there's your answer. 0.34 something. Okay? That's how you do it. And you should at least have some familiarity with this from the homework. This is a question in which you use that probability distribution again. So you have 3 teams playing in a 3-game tournament. Well, they're going to play 3 games. Each one has a different probability of winning. A, 15% chance to win a game. For B, it's 10%, and the probability of Team C to win is 65%. So what's the probability for each of these to win all 3 games in the tournament? You have 3 games, and 3-game tournament, 3 trials, and you want to win all 3 games. You just use this column right here and match it up with the probabilities. Here's the one for a tenth, 0.1 for 10% probability. The other one was 15, I think, and then 65. Well, at any rate, they won't be exactly the same numbers on the test, but you just use this table again. You're given the table also of the standard normal distribution. Here's your z-value, will be in this column. Okay. The first digits of the z-value here, and the rest of the z-value along the top. So minus 2.64 would be, let me erase this for a second. You'd find the 2.6 right here, minus 2.6, and then the last digit, the second digit after the decimal, is up here, and the 4 there. And the intersection of those two give you the area under the curve from this value of z down. It's all this. So you have to find the probability the value is less than z equal to minus 1.75. You read this right from the table. You read the 1.7 in the first column. So in this column you're looking for 1.7, and then you go over along the first row looking for 0.05. Where those two intersect, there's your value. Okay, what is the probability that the value is greater than that number? You have to find the probability that it is that number, is less than that number, and subtract it from 1. Right, so here's 1 minus the probability that it's less than that, which you already know, and so there's your answer. Now you can use that same table again, but the data is for not for a standard distribution. So in this case, here we have the number of daily admissions to the ER follows a normal distribution, but it has a mean of 60 and a standard deviation of 10. What's the probability there will be fewer than 30 admissions tomorrow? Well, first you have to find the z-score. Remember, that is given to you in the reference section. So z is the value you want minus the mean of the distribution divided by its standard deviation. In this case, it's 30, because you want to know when if there will be less than 30 admissions tomorrow. So you need to find out for 30 minus the mean. The mean is 60 divided by the standard deviation of 10, and you get a z-score of minus 3. question is, why is it necessary to compute the z-score? Because the tables are set for the standard normal distribution, for the z distribution. And that has a mean of 0 and a standard distribution of 1. So if you want to use it for a different curve, you have to scale that curve into the standard distribution, and that's what finding the z-score does for you. Then you can look up and find the probability.